In this lesson, we are still talking about the application of our exponential functions, but now we're going to be bringing in the concept of compounding. So like compounding interest here in this case. So notice how we're still kind of using that same format of the A is equal to P times 1 plus or minus R to the T power, right? Because remember, we could have growth or decay, 1 plus or minus our rate, that percentage as a decimal, right? And this was our base. We always had the original, the start, like the y-intercept, right? Then we always raise to the t power to get our final amount. So notice the compound is the same. However, I just realized this is a typo. This is not plus or minus. This is actually going to be just plus. Because when you're compounding, you're always growing in value. You're never going to decrease in value when you're compounding. So it is only 1 plus. Now notice though, we do have a new variable. Notice how we have this n here. So compounding, we're going to compound the amount in a account a certain amount of times in a year. So the n is going to represent the number of times that it is compounded in the year. So like, for example, if we say that an amount is compounded annually, well, your birthday is annually, right? So that's just 1. So that's your base A. Now, semi-annually, that means that's twice a year, right? So n is going to be 2. Now, monthly, well, how many months are in the year? 12. So we would use 12. How many weeks are in the year? 52. How many days are in the year? 365. So now notice if we see that keyword compound followed by how many times, then that is the value of n. So notice the difference now. We're going to take that rate, right, divided by that n value, and then we are also going to raise not just to the t power, but n times that t power. So like here, going back to Taylor, she opened up her account of the $300, right? That's the principal, that's the original. Here is our 6% or, so again, the rate is going to be 6 out of 100, so 0.06. And then here, we're going to calculate the amount of money in her account after 3 years. So we're going to use time of 3. We're going to still use principal 300, our rate. But now so you guys can see in practice, when the bank compounds interest, right? So here we go, compounding. So let's talk about how we would set up for twice a year, semi-annually. So if I see n or compound, I know I'm going to have an n value. So in this case, n is 2. So A is equal to P times, so 300 times 1 plus, now we're going to have a fraction, right? So our rate's still 0.06, but now we divide by the n value, which is 2. Then raise that to the t power, which is 3. But again, now we also have to multiply, right, by that n value. So here, keep in mind, now we have this to put in our calculator, and we end up with that A is going to be approximately $358.22 with our rounding. So again, just so you guys can see, let's do quarterly. So if it's compounding interest quarterly, that means our n is going to be quarterly. Now I don't have it up here. Well, so here we go. How many quarters are in a dollar? 4, right? So n is 4. So here we go. A is equal to P times, so 300 times 1 plus. Now remember, because of compounding, we have our fraction. We still have our rate here, but now divide by n, which is 4. Then raise that to the, now again, 3, but times our 4 value, that n here. So again, practicing putting in the calculator, you get that this is approximately $358.69 with rounding. So again, just to make sure we're good to go with this setup here and with our equation. Monthly, that means N is 12, right? So here we go. A is equal to 300 times 1 plus, we have our fraction, right? With our rate, but divide by the N value, which is now 12. Then raise that again to the third power, but again also multiply by 12. So that means here, practicing putting in the calculator. So if you ever need to pause so you practice putting in the calculator, and you should get with rounding, just sticking with $359. So now let's look at example 1B. Your parents deposit $5,000 into a college fund. So the original, right? We're depositing, that's our start. A college fund that pays 7.2%. So here's our rate, 7.2, right? Out of 100. That is equal to 0.072. Again, dividing, put that in your calculator. Now notice that's your interest compounded, right? So here we go. What is our N value? Compounded how often? Monthly. So N is what? 12. Find the account balance after 5 years. So here's our T. So again, see how we have that keyword compound? How often? 12. So here we go. A is equal to 5,000 times 1 plus, we need our fraction, right? 0.072, but divide now by the N value, which is 12. Then raise that to our T power of 5. But again, don't forget to multiply that exponent by also what? 12, the N value. So now pause the video, practice putting this in the calculator and see what you get. And you should have gotten that this is approximately $7,158.94. So now go and pause the video and try the you try on your own. And so now here, as you were reading through, you should have seen that the 20,000 is your start. Here we have an interest rate of 8%, so that means R is 0.08, right? 8 divided by 100. You should have also noticed right after that, compounded. So we do have an N value, compounded how often? Weekly. So that means your N is 52. Then we are assuming that the investment is 18 years. That is your T. So here we go. We're looking for that final amount. So A is equal to 20,000 times 1 plus your fraction, 0.08, but divided by what? 52 here, right? Then raise that to the T power of 18 times 52. Now, I haven't mentioned, but if you're trying to put in the calculator like this, you might have some difficulty because maybe this times 52 might come down and you're getting different answers. My suggestion would be if you're trying to put all of this in the calculator at the same time, put your exponent also in parentheses as well. That will keep it all together here. So make sure to try that. So you should get, so if you need to repause and try and make sure to see if you get the right answer, go ahead and do so. Otherwise, you should get that the final amount after 18 years, right, is $843,205.59. So now there's also what we call compound continuously. So if we see compound continuously, this is now a separate formula. So notice now, and this is what we call like PERC. A is still the final, P is the principal. Now our rate and time are now the exponent being multiplied together. Now notice E. E is not actually a variable. E is actually this irrational number here. It's like 2.71. It just goes on and on and on. And if you look, if you need to, pause the video and locate E on the calculator. So there is E on the calculator. And you'll see it with what we call our natural log, ln. n. So you'll see it with ln, and we'll get to that later down the road. So we are going to use this value, e, 2.7182, blah, 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 raise that to the rate times time power multiplied by p. So that's if we're compounding continuously, okay? So like going back to Taylor. Taylor has that initial amount of $300 in her savings account, but now notice we are compounding, right? How often? Continuously. So this is per. The moment that we see continuously, right? We're going to use E. Still at that rate of 6% or 0.06, right? 6 out of 100 and 5 years now. So T is our 5. So here we go. We have A is equal to the principal 300 times E. We're going to raise that to the. So again, if you need to, put in parentheses 5 times 0.06, or again, 0.06 times 5, it's all the same, right? Commutative property, 5 times 6 is the same as 6 times 5. So now if you need to, pause the video if you haven't yet, locate E on your calculator and practice putting this in to see what you get. And you should get that the final amount is approximately $404.96. So again, let's do another one here, right? So we've got an investment of $1,000. So here's our principal, our start, at a rate of 3.5% or 3.5 out of 100, right? So this gives us 0.035. Then notice it says, boom, compounded, right? How often? Continuously. So we're going to use E, right? We're not going to have an end value because we're compounding continuously for 8 years. Here's our T. We're going to find that final amount. So again, here we go. A is equal to 1,000 times E. Raise that now, right? If you need to, put in parentheses. Rate times time, 0.035 times 8. So again, pause the video, practice putting that in the calculator and see what you get. And you should get that the final amount is approximately $1,323.13. Go ahead and pause the video and try this you try now on your own. And here we go. So here you have 2,000, that's your principal. You should have noticed 9%, so your rate you should have gotten is 0.09, right? 9 out of 100. You should have also noticed, here's our keyword compounded, how often? Continuously. That's why we're using E for 12 years. So that is your T. We're finding the final amount. So A is equal to 2,000 times, oops, sorry, my fault, 2,000 times E, raise that to the rate times time power. Then you should have gotten approximately $5,889.36 with rounding.